Okay, so ice is our final stage. So let's look at the various stages that each of these samples has to go through. So let's look first at the heating of ice. Okay. Okay. Our ice starts at minus 15 degrees Celsius. Okay, and it's ice. And it warms to our final temperature as ice. Okay? Now what about the liquid water? Okay, what about the liquid water? Well, it's 20 degrees Celsius water. Again, water refers to liquid water here. Now, to get to this final temperature of ice, it has to warm up to 0 degrees Celsius water. But then it has to change phase. It has to become 0 degrees Celsius ice. And then it has to cool again to the final temperature, which is ice. Okay? So that now both our samples are at the same final temperature. Okay? So our ice has only one stage of heating. It warms from minus 15 to some final temperature. But the sample of liquid water has to go through 3 phases of cooling. It cools from 20 degrees Celsius to 0. But then you have the phase change. It changes over to ice. And then finally it warms as ice to the final temperature. Okay, so let's go ahead and apply this then. And I'm going to erase the top part up here. I'm going to erase this even. Okay. So, our expression then for heat is that Q of the cold sample, which is ice, equals the negative of the hot sample, which is the liquid water. Okay, so let's calculate Q for the ice. Okay, so Q for the ice, well, remember Q is mc delta T. Okay, so the ice then has a mass of 1.2 kilograms. There's M. C, the specific heat of ice, is 2090. And now we need delta T, which is final temperature minus the initial temperature. So the initial temperature of that sample is negative 15. Okay, so TF minus 15, that becomes plus there. Okay, so there's Q for the ice. Now let's calculate negative Q for our water sample. And remember, we have 3 stages of heating. So let's go ahead and erase some of this stuff here for ice. Okay. So to calculate Q for the water, we need to consider these 3 stages. And we're interested in negative. Okay, so we need to calculate negative of the Q from water. Okay, so our first stage of cooling, 20 degrees Celsius to 0 degrees Celsius as water. So mc delta T, we have a mass then of 0.01. Specific heat of water for this, because it's water, it's liquid water, the specific heat of water is 4190. Delta T, our final temperature is 0, initial temperature is 20. So that gives us minus 20 for delta T. Temperature has cooled by 20 degrees. Okay, so that's our first stage of heating. That's this stage right here. Now we need this stage of heating, the change from 0 degrees Celsius water to 0 degrees Celsius ice. And the heat for of fusion is what we're interested in. Is for freezing, it's negative M mass times heat of fusion. So that's what we need for the phase change. The negative comes from the cooling, from the freezing. Now, if we were going the other way, we went from ice to water, well, this would be a positive quantity. Okay? But we're going from water to ice, so our heat then is a negative quantity. Okay? So therefore we have negative mass of our water, which is 0.01, times heat of fusion of ice, which is 3.33 times 10 to the 5th. Okay, so that's a 5 there. Sorry about my handwriting. Okay. Then finally, we have, that was this stage. We have our last stage of cooling. We have our sample 0 degrees Celsius as ice cools to our final temperature as ice. Okay, so then we have another MC delta T in here. Mass is 0.01. Now, this sample, which was originally water, is now ice. So we have to use specific heat of ice here. So the specific heat of ice is 2090. And the temperature change, it's T final minus 0. T final minus 0 is just T final. Okay, all in the brackets there. Okay, so this has to be equal to this whole thing. Okay, Q of the ice equals the negative Q of water. So let's multiply that out. And when you multiply it out, you get this. You get 2508 T final plus 37620. Okay, that's what happens when you multiply this stuff out up here. That equals 4168. Okay, that's what you get when you do this and this, and then take the negative of that whole thing. Okay, so 4168 minus 20.9 T final. Okay, 20.9 is that times that. Okay, so we just need to do a little bit of algebra here, solve for the final temperature, and the number you get is minus 13.5 degrees Celsius. Okay, so we started out with our minus 15 degrees Celsius ice, and we basically just added a few drops of water to it. It just warmed it up a little bit.